Hello everyone, welcome to the sixth session on Terraform on AWS. In this session, we will be seeing how we will be building a three-tier VPC in AWS with web, app and DB tiers using VPC Internet Gateway, NAT Gateway, Elastic IPs, route tables, routes and public and private subnets. So in AWS Cloud, first we are going to create a VPC and we are going to create the subnets public and private for two availability zones. So this is one of the availability zone and this is one. And here we will be building one public and private subnets. So this is zone A and this is zone B. We are also going to create two more private subnets for databases. So this is one and this is one for each availability zone. We are also going to create the internet gateway, this one, and then add the routes for the public subnet so that inbound traffic is allowed via these public subnets. Okay. We will also create the NAT gateways with elastic IPs so that the private subnet for EC2 instances will be able to communicate to the internet using this NAT gateway via internet gateway routes. So as a part of this lecture, we will be building this three-tier architecture of VPC using Terraform, and we will also see the Terraform module. So as a part of this lecture, we will build this VPC three-tier architecture using Terraform. Also, you will learn about Terraform modules as part of this respective session. So how to use them published on the Terraform public registry. We will use that module and create a VPC and will define multiple input variables for that VPC. So before proceeding, let us first see what is Terraform module. So modules are containers for multiple resources that are used together. A module consists of a collection of .tf files kept together in a directory. So in simple terms, module is nothing but a reusable thing where some functionality you have automated and that functionality you can call as a module. Modules are the main way to package and reuse resource configurations with Terraform. Every Terraform configuration has at least one module known as its root module. So whatever you have implemented so far as part of this course are root module, which consists of the resources defined in the .tf files in the main working directory. A Terraform module, usually the root module of a configuration, can call other modules to include their resources into the configuration. With that said, a module that has been called by another module is also referred as the child module. So child modules can be called multiple times within the same configuration and multiple configurations can use the same child module. In addition to modules from local file system, Terraform can load modules from a public or private registry. So you can call modules from the local file system. This means you can create a custom module by yourself and call it from local file system based on the requirement whatever you have. Or you can leverage and use lots of modules published in the Terraform public registry. Or you can also create a module and publish it on the Terraform Cloud private registry and call that for your need. This makes it possible to publish modules for others to use and to use modules that others have published. So let us go to Google first and let us type here Terraform module. Terraform, let me see, AWS VPC module. So as you come in here, you can see the providers and modules are there. I have already told earlier, these providers will primarily focus on AWS, Azure, GCP and other multiple providers. And modules are the reusable things whatever they had published. So till now, 1674 providers are there and 7611 modules are there, and this is increasing day by day. So let us browse these modules, and here you can see this VPC module, which is nothing but by calling this reusable module VPC from the public registry of Terraform, you will be able to create the VPC in AWS. And you can see here that this is verified. Now, since this is verified, so you can use it at your own convenience without any issues. If it's not verified, then you need to work on those, and it might be of a risk factor also. So this states the authenticity for this module. And also you can see from the total provisions, see you can see 15.5 million provisions. You will be able to decide whether you can use this module from the public registry or you need to build your own module based on your requirements. So this verified badge and this provide total provisions, from there you can estimate whether this can be used or not. If you are proceeding with creating the VPC resource, then that means there are many other things that which you need to create, like internet gateways, route tables, security groups and more. So it is for these internet gateway, route tables, security groups and more. For that you can check our AWS session where we taught on it on AWS VPC, internet gateways and route tables. So you can check that session if you have not, if you don't have much knowledge on this. So it's easier to proceed with the authentic modules for VPC rather than creating the resource VPC, since there are many things you need to create like internet gateway, route tables and all. So it will be much difficult for you and to create each and everything by custom. So if you use these verified authentic modules, then your work will be much more easier. But if some features are not present inside the modules and those features you aren't able to tie within the VPC module, even after creating those features via resource, then you need to proceed with the resource creation. So these decisions need to be made by you, whether you need to create each and every VPC resource if you are proceeding with the VPC resource, or you can take this VPC module. And also from here in the README, you can get a detailed information about everything, like the external NAT gateway IPs, NAT gateway scenarios and all, everything, every detailed information you will be getting in this README. Likewise, similarly, from resources, you will come to know how many resources are supported in the respective module. So you can see there are, this module defines 76 resources. So currently 76 resources are supported in this VPC module. So in this respective module. Also from inputs, what inputs which are required or optional inputs, required inputs. Okay. So these you will be able to provide, what all you will be able to provide are given in here. Similarly, from outputs, what outputs from this VPC you will be able to take, like the CGW IDs, the internet gateway, the NAT gateway, network ACL, route table IDs, and many more things. These you will be, the CIDR blocks, these things you will be able to get from here. Okay, and this is very important, as whatever the outputs you are going to take from here will be referenced in other modules like security groups or load balancers. Also, you need to verify whether there are any module dependencies or not, where it says the AWS provider should be greater than equal to something. We'll be having this VPC module where we will be having three files: versions.tf, generic variables.tf, and vpc.tf. So these three configuration files will be there. And in vpc.tf only, we are going to create the Terraform module. So let's consider these three files as the root module. And inside VPC, we are going to call the child module, whatever it is present in the Terraform public registry with inputs what you are going to provide. So let us go to our Visual Studio Code. So in here, let us make another folder, and in here, let us create a VPC module first. Let us proceed with the versions.tf. So in this versions.tf, no changes will be made in here. So let us copy this and paste it in here. Okay, done. Now in generic variables, so we will be having vpc.tf, versions.tf and generic variables. In generic variables, let me just edit it. in here we will have only the AWS region present over here. So let me just put it. Let me give the description as region in which AWS resources will be created. Okay, and let the type be string and the default region let it be US East 1. Okay, so we are fine with our generic variables too. Now let's go to VPC.tf. Let us make this, and in here let us comment it as create VPC Terraform module, and let's go to the VPC module first. So here we are in our VPC module. So here you can see source code is there. So let us open the source code in another window, and in here you can see a series of .tf, means the configuration files are there in here together, and this series of .tf files in here is together called as module, and there are examples for each module also in here. Okay, like this. In here also, if you see, you can see from this drop down menu, you can see that you will be getting lots of examples, and let's click on this VPC. Okay, here let us go to this source code, and you can see the main.tf over here. Well, this one is a little bit advanced because many things are there which most of them we won't be needing also. So let us do one thing. From this VPC Terraform VPC module, let us copy this provision instructions and paste over here. Okay, done. So here this VPC is just a name which you can put whatever you want. You can put infra experts also in here. You can put your name also over here, whatever you want. So, and this is the source from where it is taken it, and this is the version 3.1.0. Unlike providers, do not use here this symbol. Okay, why? See, in here, in provider, here we are putting this symbol. This means, say, anything greater than 3.0 or equals to 3.0 will be taken. So 3.1, 3.2, likewise everything will be taken. But in here, if we are putting like this over here, so what will it be doing? It will be taking some other versions also, and it may break the updates of your existing provider module. If it's custom module, you can use this, but if we are taking from these third-party modules from this Terraform public registry, always try to use the specific version by using by given like this only, which is provided, and block it using the equals to sign. Okay, and now let's go to the main.tf in the complete VPC. So this is the main.tf, and in here let us go at first. Here let me take this name and the CIDR block. Okay, and paste it over here. Here I'm going to change this as VPC -test. Okay, and the CIDR block I'm also going to change it. So what will I be putting it in here? 10.0.0.0. Okay, so this is my CIDR block. Now again let's go to this, and in here what things we will be needing? We need these from availability zones to database subnets. So these are needed as per our diagram which we are going to planning to make, that availability zones are there, public subnet, private subnet for database and EC2 are there. So we need these to be kept in here. Okay, let me give here VPC basic details, and here also these are fine. Here what I need to do, I will be just deleting them and I'll just put two availability zone, US East 1A and US East 1B. Okay, why I am using these two availability zones, because if we are putting some more zones over here, so the number of availability zones increases, so which will increase the number of EC2 instances also, and which would in turn charge us more. So for this demo purpose we are proceeding with two availability zones, and which we already saw in our diagram also. Now the private subnets, let it be. So if you go in here for this private subnets and search it in here, you can see here that the private subnet, in list of private subnet, which is, and this is showing here, list of string. Okay, so if you have any doubt on some parameters, you can find it type by coming in here. Okay, so the private subnet, let me put it as 10.0.1.0/24. Similarly, let me just copy it. Let me give it as 2.0./24. Okay, and for public subnets, also similarly you can check it in here. See, for public subnet, this is also list of string, and it starts with like this. Okay, so for public subnet also, let me keep it as 10.0.101/24 and 10.0.102/24. And next comes our database subnets. Now we want this database subnet group to be created, and for that let us go in here and search for create database subnet group. So you can see in here, create database subnet group, create database subnet route table. So these two I need. Okay, and let me just copy it and paste it in here first. Now what does this depict? Create database subnet group. I want this database subnet group to be created, that's why it is true. Create database subnet route table. So I'm not putting the, I need this database subnet route table to be created, that's why I'm keeping this. Okay, and I'm not keeping this create database internet gateway route. And one more thing, I won't be keeping that create database NAT gateway route also in here, as I don't want this to be publicly accessible. Okay, and now the database subnets, let me keep it as 10.0.151.0/24, comma 10.0.152.0/24. Okay, so this is fine. Now I need to enable NAT gateway for my private subnet. Okay, so NAT gateways for outbound traffic. Now if you see in here, enable NAT gateway. Okay, this should be true if you want to provision NAT gateway for each of your private network. Okay, so by default this is false, but here we will be making it as true. Next is single, we have this parameter single NAT gateway. Okay, we need to search it like this every time. This should be true if you want to provision a single NAT gateway across all of your private networks. Okay, so this is by default, it is false. We need to make the single NAT gateway to true, or else each AZ will have their each NAT gateway, and which will induce more cost. So let me make it as true because the default is false. And then we need to have the DNS parameters also in here. Enable DNS. So enable DNS hostnames and DNS support, these two we need. Okay. As you can see in here, should be true to enable DNS hostnames, should be true to enable DNS support in the VPC. And by default, DNS hostnames is false and this one is true. Okay. But I need this to be enabled. So I'll just copy it and paste it in here. Okay. Done. Next comes the subnet tags. So this subnet tags, this will be something like additional tag for public subnets. Okay. And this is with map string. Okay. Let me give the public subnet tags and let me give the type as public subnets. Fine. Similarly, let me provide the private subnet tags, the type being private subnets. Fine. Next is database subnet tags, and in here the type database subnets. Okay, fine. Next we'll be having the regular tags also in here. So the regular tags will be tags equals to, then let me give the owner name, let it be infra experts, and the environment, let this be as test. Okay. And also we'll be having one more tag which is VPC tags, and let this be as VPC hyphen test. So we are done. Now I'll use whatever is related to our resources and paste it in our outputs.tf. Okay. So let me make another file and in here let me just paste it. Let me go in here and check in here. Let me check this. I'll be taking this VPC ID. Let me just copy it and paste it in here. Next I'll be having, and this value, let me just change it to module dot VPC dot VPC underscore ID. Okay. And then let me take the subnets too. So we'll be having the public, private and database subnets. So let me check in here. I can take this CIDR block also. Let me have this CIDR block, and the model which will be taken is this one, and VPC CIDR block. Okay. Then the subnets I will be taking. Let's see where the subnets are. Private subnet. So this is the private subnet which I need. Similarly, I need the public subnet and the database subnet also. Okay, where is the database subnet? So this is the one. So I'm keeping this, and now I need to change this. So this is done. Now I need the NAT gateways also. Okay, let me search for the NAT gateways where I can get it. Basically I need the NAT public IPs. So I'm having this. Now let's test our module. So we are done. Let us just test the module. So we need to go to our working directory first. Okay. And run Terraform init. This will be failing. Why did it fail? Could not download module vpc.tf source code this. So this is not available. So the Git must be available. and the path error on the path, this error indicates that you have not installed Git in the path on the system you are using. So you will need to install your Git software and then mention the path in the environment variables if you want to use modules that are fetched via Git. So let us just download the Git software from here for Windows. So this is downloading. Now once it is downloaded, I need to install it. So this is downloaded. Let me just open it. Next. So this will be installing my Git over here. I'm just installing this with all the default setup itself. So it got installed. Now what I need to do, I need to mention the path. So for mentioning the path, let me go in here, and here my git bash.exe is there. So this path I need to mention in my environment variables, system environment variables. Okay, so in here let me give the path new and then paste it in here. So this is done. Now we will be fine and we won't be getting this error again. Sorry, I need to open a new command prompt. And now run Terraform init. So if my code is fine, then everything will be working fine in here. So you can see that right now it is initializing the modules, and here you can see VPC and in .terraform/modules/VPC is present. So you will get all the stuffs from the path. So let us go in there. Let us go to here, 6th session. In .terraform, if you go to modules, you can see modules.json is there. So here you will be getting the information about your provider. And if you go to VPC, you can see what all I showed in here, like the Terraform code in the source code. Let me just click the source code. You can see these files. These are already downloaded and kept in here. Okay. So entire module information is here, and this is the same what you see in here. Okay. So that's what happens whenever you run this terraform.init by calling the child module. Now let us go ahead and validate Terraform validate. So unsupported, see, there's some issue with this stages it became. So let me go to VPC, see in here my configuration was not valid. Now let me try again. So my configuration is currently valid. Okay, now let us proceed with the Terraform plan and check our execution plan. You can see all the values are hard coded here. So total 22 resources will be allocated over here. So you can see here, if you go at the start itself, let us go at the beginning of my Terraform. So create, so one DB subnet group will be created in the, then for this module DB subnet group, so one elastic IP address will be created, one NAT gateway will be created. Like this, many things will be created, and out of which let us check down. This is the main VPC resource in this output of Terraform plan. So you can understand the flexibility using modules simplifies a lot of things, and these many things will be created over here. You can see the output.tf files also getting generated. Okay, now let me run the Terraform apply with auto approve. Okay, so it won't be asking for my approval, and it will be just simply going ahead and creating the resources. So I will pause the video until this is created. So my resources have been created, and you can see the output is also provided over here. And if you go in here and go to VPC, in VPCs you can see that VPC test has been created, and this is in US East 1 region. Okay, and you can see the IPv4 address over here. Similarly, you can see that the subnets are created for two availability zones, public subnet in two availability zones, private subnets in two availability zones, and database subnet also in two availability zones. And route tables for public, private, and database have been created. Similarly, if you click in here, you can see that it is associated with the internet gateway and its equivalent public subnet associations are also present. Okay, similarly for private also, you can see it is associated with the NAT gateway. So private route via NAT gateway is enabled, and subnet associations are there. But for database, in this you can see in the route table only the internal route related to 10.0.0.0/16 is enabled, and VPC testnet subnets are also associated, and internet gateway is also created. Similarly, NAT gateway should also be created. See, it is created. So we have seen here how to create your VPC, and with all the subnets, internet gateway, route tables, and all over here through the VPC module. So now let us go ahead and destroy our resources. So in this session, I hope you have understood how to use your public modules to proceed with creating your resources and all. Hope you have enjoyed the session and you have gained some knowledge from on top of it. Thanks a lot for watching the session. Take care. Please do like, share, and subscribe. Thank you.